lowest number. Yeah, okay, I can use that fact. So that means any number equal to or below it has to work, has to divide it. But how do I formally prove it? Well, okay, so if number exists such that it's less, but GCD is not multiple, but then we account for the number when we calculate GCD itself already. So that means GCD will be at most that number. So if it is not multiple of that, it has to be lower. So I run into a contradiction. Therefore, this fact must be true. Okay. I think I know how to solve
Okay,
Q.
I guess live stream is running.
Time to solve Q, boys. Woo!
Nice.
Okay, first,
Pretty impressive.
first,
Sorry, helping my friend with her exam. But yeah, you're fucking doing pretty good.
first step to solving problem is reading the input. If you can't read the input, just quit competitive programming.
That's too harsh.
Either you learn how to read input or you quit. Yes. It's
I'm just making my setup for the contest for now.
You have a setup? My man.
I mean, just creating the files for the problems. Then later on,
Real
then
chat
Whoa,
is
how
work
long have
with
you been in
one
here?
file.
I can barely hear you, Chico.
what?
Or maybe I just have Felony turned up.
Uh, Maybe the sound is turned off.
I can hear you now.
You can hear it
Let's
now.
see.
Yeah, I just had my volume down. And I had him turned up, so.
Okay.
While t minus minus.
Oops.
Okay. I
Okay,
guess
now
it's
I'm
up
just
for
gonna
debate
play.
whether segment tree is fundamental or not, but it sure helped. Okay. Segment tree. Oh, maybe. Ah, shoot. Two segment trees? Disgusting. Absolute disgrace. Merge. Merge. I'm gonna GCD your house. Okay.
Okay, now I'm gonna focus on it. Okay.
speed run time.
Decrease a number by 1. Okay, if the number has 2 or more digits, he has problem decreasing it.
I just clicked the general chat and I see a picture of that girl from ReZero. Immediately give me 10 out of 10 vibe check. Congrats.
Yeah,
I did not know someone here watches ReZero.
I do.
What a man of culture.
There's a ReZero car on my house. It's like completely covered in ReZero stuff.
I'm guessing you're gonna watch, what is it, season 3? I think it's coming out.
Oh, okay. NK.
Man, I love GCC.
Okay, 50. And the next one is 1. Okay. Oh, I forgot to log in. Okay, Jacob, do you think it's better to solve the problem first and explain it afterwards and before diving next to the next problem?
Can you explain it as you go?
What?
Can you just explain it as you go? You might have to think about it first.
As I go.
Yeah, that would be entertaining.
Okay, so I'm just gonna draw it then.
But it would be hard without a script. But then you're not supposed to have a script because it's a contest.
What?
Yeah, no, just try it.
Okay, okay. So today's contest is August 9, and I'm gonna start up with A. So A is literally if the number ends with something other than 0, then you remove the last 0 and you should end up with the remaining digits. And if it's something other than 0, like for example x, 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 and 1, you just subtract 1 from the last digit. So it should become like 0. And you have to do this subtraction operation for k times. So that's basically it. So on each iteration, I decremented my k by 1, and I checked if the last digit is not equal to 0, and if that's the case, I decremented it by 1, and otherwise twice, I divide it by 10, and then you get the last answer.
I wonder if Python has sort of a ordered set. Oh, it's called sorted lists. Yeah, I remember. They're correct.
How do you open YouTube stream chat on the side? I don't see any chat. Okay, I'm gonna mess with this later. Okay, now let's get into B. Okay. Single line contains set of letters. The line starts from small English letters are listed. Okay. So for problem B, first we need to read the input as string S, and we can run through each character, and we can literally put them into a set, or we can just mark them in just array, whichever works. Oh, I cannot name it as set again. Probably name it as st. Oops. Okay, before inserting it to my set, I have to verify if it's English lowercase alphabet. So that means it has to be lower than lower d and greater than lower a. Okay, let's see. And we don't have multiple test cases. Oh no, it says only one. Lower than z, greater than a. That is the case, we insert it. Okay, what is this only character that is being stored in my set? It's A. Is there anything wrong here? Oh, when I read the first string, it's reading only up until the first comma. So instead of this, we need to use getLine. I hope you
Okay, back to the problem at hand.
Okay. Oh, this test case n is pretty large.
What is the formula for x? Okay, to the
One approach is we can check until the square root of this number. Oh wait, greater than 1. So that means basically if if the given number is odd, we can literally just print out the given number if it's greater than 1. And otherwise we can divide it by 2 until it's odd and check if it's greater than 1.
section.
Okay. While n is even, which means n divided by 2. Oops. I'm going to divide it by 2, and at the end, if n is, we can print it in one line. If n is odd, which means n has the last bit, then we're going to.
So now I have
No,
this.
wait. If n is greater than 1, then we say yes. Otherwise, no. Okay. Yeah, no, yes, no, yes, yes, no. No, yes, no, yes, yes, no. Okay. I think it works. I think it works. Then we can get into the next problem. Hit the lottery. Oh, okay. Oh, as you can see from these numbers, the higher number always can be divided into the lower bills. So for example, you can always get 100 by using several bills of 20s, and you can always get 20 by using several bills of these 3. So that means the greedy approach can work. So that means you can always get as many bills as you can from this one, and as many bills as you can from this one, and so on. Oh no, I don't need to create new file.
Okay. So this one will be say create a query.
Okay, I can just create array for the bills, which is 100, 20, 10, 5, and 1. Yeah, Selena just told me that you don't need to define the type if you initialize it with some initial numbers, initial values. If it's greater than 0, oh wait, first I need to just run through the bills. I'm just gonna run through the bills and wait, what is the largest number? It's 1 billion, so it should fit in just integer. So I'm gonna start the answer in ants. So ants should incremented by n divided by x, and n should get divided by x. Yeah, that should be it. Oh, he said it's C++ 17 feature. Yeah, it says 3. It says 5. And it is 10 million, I guess. Yeah, these are gonna load forever. Wait, did I not submit my C? Oh. Okay, I submitted first floor. Okay, before this sentence, this problem, this is not related to the problem. So sometimes you need to focus on that. Okay, we need to only check if the sum of all vectors is equal to 0. Okay. Okay, so which means sum of each column has to be equal to 0. Okay. And we can just find the sum of all columns. So basically, as it said, oh no, I shouldn't create new file. already created it. And coordinates are from -100 to +100, and we will have at most 100 coordinates, so which means we can just use integer array. We can initialize it with 3 zeros, and we're going to take 3 coordinates of each vector. Oopsie. And for each component of every vector, we're going to read an integer, and we're going to add it to our sum of j. And finally, we need to check if either of 3 components of sum not equal to 0, we're going to say no, it's not equilibrium, and otherwise we're gonna print yes. Redax and increment the sum for jth column. Okay, let's try it. First one is no, and second case is yes. Okay, on the output it said only capital yes and only capital no, so we need to change it. Okay, yes, no. Type and log onto the internet. Oh, okay, so basically we need to find subsequence from the given string, which is hello, which makes hello out of it. So subsequence is just the string that you get by deleting several characters. So for this case you get these 4 characters and this 1 character, which makes hello. Okay, let's read the input first, and we will have only 1 input. Okay, and what I think is we can just we can store that word in another variable, it's hello, and every time we hit some character of the word, we're just going to increment the index. So first we're going to iterate through the initial given string, and if c is equal, first we need to verify if index is less than word.size, and if c is equal word and int, we're going to increment the index, and at the end we only need to check if index is equal word.size, And if that's the case, that means we visited each character of the word hello in order somewhere in the string as a subsequence, and then we're going to print yes, otherwise we're going to print no. And this is problem F. First one is yes, and second one is no. Submit failed. Oh, I see. Some of my submissions are just failing. It's not a problem from my end, it's a problem on the server. Okay, so basically you want to wait each morning. Okay, each morning you can put any number of bacteria into the box, and each night every bacterium in the box will split into two. Okay, what is the minimum? Okay. Into the box across those days. So it's literally number of bits in the initial given number. So how this works is, okay, problem G. So as you can see from the test case, if you want to have exactly 5 bacteria, you will need to put 2 bacteriums. So 5, if you put it in binary, is 101, and each night your bacteriums are doubled. So basically you're adding 0 after it. Like after several nights it will add only zeros, but you cannot add ones unless you put it. So the number of bits is the minimum bacteriums that you need to put into the jar. And you read X, and basically what you need to do is count the number of bits. I think there is the built-in function to count the number of bits in given integer, but I'm gonna do it in this way. The reason I'm running only until 31 is because 2 to the power of 31 is more than 1 billion. So at most then our given number is gonna have bits up until 2 to the power of 2 to the power of 30, so it should be enough. So we shift the 1 by I times to the left, and then we're going to AND it. So if the AND result is other than 0, not equal 0, that means our X had bit set on ith bit. And we're just literally going to increment our answer. see. Oh no, I ran the wrong program. Should be G and 2 1. Okay, it's good. Okay. Okay, so there's literally n different shops that sells this drink, and at each shop the one bottle of this drink is equal to xi coins, and he wants to buy it for q days, and each day he can spend up to mi coins, and for each day he wants to know how many different shops he can buy a bottle of bicola. Okay. Okay, for this problem we can just sort this array and build the prefix sum out of it, and for each query for each day we can just do binary search on that. Okay, I guess it was problem H. Okay, we're going to read n first, n, and we will read x and q and mi. Okay. We can also run through each element of the array by reference and assign the value directly into it. Prefix sum, I'm going to initialize with initial zeros. And then we're going to have q. For each q, we're going to have m, which is the maximum number of coins that we can spend every day. Oh, let's check the overflow first. So 100,000 times 100,000 is 10 to the 10th, so it's going to cause overflow if you only use integer for the prefix sum. So we need to use long for the prefix sum, and then we're going to do a binary search. In sorted array, you can just do a binary search by upper bound. And since this upper bound returns an vector iterator, you can just subtract the begin out of it to get the index. And also for this case, index is the number of different shops that you can visit. Let's test it. 0, 2, 1, 2. Oh no, first. Okay. Oh, like you don't need to visit everyone. You just need to, like, okay, for coin 10 you need to visit, like, obviously for 10 coins you cannot buy this big cola from, like, you can at most visit the first one and the fourth shop, right? But what problem is asking is how many different shops you can visit. Like, you don't necessarily have to visit them and buy Picola. Okay, so for that case, we don't even need to set up this pre-sum array. We just need to do binary search on the initial one. Okay, it looks good. Okay, it's submitted. And problem I. Okay, we have N boys and M girls. Okay, so each partner's dancing skill can differ by at most one. Okay. So basically we need to find what is the maximum pairs we can get out of N boys and M girls if the partner's dancing skill can differ by at most one. Okay, so for this case we can sort the boys by their dancing skill and sort girls by their dancing skill. And after that, we can match them greedily. Yeah, so this is problem I. We're going to have N boys and N girls, and I'm going to get the input of boys dancing skills in array A and girls dancing skill in array B. Oh wait, I forgot to read N first. Then let's sort it right away. Let's sort girls by skills to 2, and then we can just have 2 pointers which both initially points to 0, and while L is less than N and oh, this should be R. R is less than M, so L is basically the boys iterator and R is the girls iterator. So if AL, the absolute difference, the absolute difference of AL and BR is less than 1, less than or equal to 1, we're going to make them a pair. Oops.
Ooh, 2 poems left. Jeez.
Only 2 left?
Yeah, P and R.
Nice. Okay, and for if we cannot pair them up, we're going to increment the pointer of whichever the less. No, we get only 1. Why is that? We can match this with this one and match this with this one. And that is 2, and match this with this one. Okay, what went wrong? Oh no, here we could not initialize B like that. Yeah, we can only initialize with size B after reading M. Like, we can only initialize vector with size M after reading the M. Otherwise, it's gonna be like null. Yep, we got 3. We got 0. And we got 2. Okay, N participant of the competition. M teams. At least 1 participant. Okay, minimum and maximum number of pairs of friends that could have formed by end. Okay. Okay, if we put 5 participant into a single team, each 2 participant can become friends. So that makes it 10. Okay. we split 3 people into 2 teams. One team is gonna have 1 participant, another team is gonna have 2 participants, and only those 2 participants who are in the same team can become friends. I see. Okay, for this problem, I just feel like the maximum case is like first we have m teams, right? M team, we can just think of it as m buckets, and we put one member, one member, one member to each teams except the last one, and the last one is gonna have n minus m plus 1 members. Oops. Can I have extra space to the sides? Okay, no. And the number of prints we can get out of here is like if we say x is equal to n minus m plus 1, the answer is x times x plus 1 divided by 2. Is that correct? No, actually it's not plus, it's x minus 1. And the minimum case is if you distribute the participants evenly to each teams. So that case is like we have m buckets, and for each one of them we're going to put n divided by m participants, and so on, and the last one is gonna have n divided by m plus the remaining participants. And let's okay, and also last n divided by m with remainder. Okay, teams gonna have plus 1. So now now the sum of participants in each team is gonna be n in total. Yeah, this is for those who don't know this, this is just the remainder you get by dividing n by m. And for this case, the answer is m minus n divided by m. So this is the number of these buckets, right? And times n divided by m times n divided by m minus 1 and divided by 2, and plus n divided by m, and now this is the number of these buckets, and this number is number of prints that you can make in each one of these groups, times n divided by m plus 1 and times n divided by m divided by 2.
running my solution for Q against brute forcer. So far, found nothing. Whew, I think it's correct. I
Nice.
don't have I don't have the V just in telling me whether it's right or not, so I'm writing a brute force checker.
Oh, did you submit it directly to Codeforces?
Oh my goodness, why did I not think of that? Ah, I could
Wait,
have gone free cloud if I just submitted code forces.
wait.
You're
Then
right.
how did you check if it's correct or not?
Well, I still don't know for sure, but I wrote a brute force checker.
Oh, okay. Yeah, you can just submit it to Codeforces.
I forgot everything here has a code forces problem.
Yeah, it is. Okay.
Wait, no shot. It's F. It's problem F. Wait, this seems too easy for F. Wait, no, no. There's no way. Like, wait,
Like in
please,
Division 3 or
wait.
Division 2?
It's div 2F.
Div 2F? Oh.
Wait, time limit exceeded. No. Wait, it's only 1 second. Ah, shoot! I have to make it fast. No. Oh,
Yes, okay. Problem J.
dang it.
Oh yeah, I just read it and solved it. Wait, first
Ah.
can you read N and then M?
How big is the test case? So pissed.
So
But yeah,
since
yeah,
the
problem
huh?
Q is div 2F. So now you know.
Okay.
Whoever set this problem has issues. Who the heck makes it 1 second? Who, who does that, bro? They make it two, please. Like, what did people do to you to make you set it to 1 second? Do you just want to see people fail, even with a good enough time complexity?
Yeah.
Oh man.
He
Well,
just wants
back to
you
the
to
drawing board.
write better program, bro. Okay, I need to check the formula. Oh, it's actually M minus. -1. Divided by 2. Divided by 2 plus.
I see. So, oh yeah, by the way, problem S is a div 2E. So there you go.
Okay, okay.
Okay, let's take my brain that this works. Submit. Please. Oh. Bring me
Oops.
some test 25. No. Oh, of course it's because of overflow. Oh my
Yeah,
goodness.
you're right, because of its overflow.
Freaking
Oh
overflows.
no. No, it's even
Long,
worse.
long
Oh, I'm reading T
answer.
test cases.
0.
That's why. Okay, 10 10. 1 1 and 3 6.
Answer. Difference. Bucket. This should be fine.
Being a programmer, you like arrays a lot and distinct integers. I've seen a lot of these weird problems, like like people like to get array on their birthday.
Come on.
Ace.
Past 25. AC, yes, yes, yes. Div to E solved.
Nice.
Woo!
Okay, so basically you need to check if after reversing one segment of the array you get sorted array or not. So for this case you can reverse this. For this case you cannot, and yep. Yeah, we've seen this K before, right? Silani?
Wait, wait, I just gotta confirm. Yeah, I just copied the solution from last time. I can't be bothered to code this crap again.
Oh, okay. Okay, I'll try to code it again. Yeah.
I mean, there has to be like an easy way to do it, but I mean, my code is kind of elegant, required a lot of thought.
Uh-huh. And I have to check. Okay, so basically for this problem, K, it has to be like increasing at first and decreasing and then increase from here. I draw it a lot. I can draw it better. Increase at first, decrease, and increase. And then it's yes. And also this tail should be greater than this one. Okay, so if this is the case, we can just find this segment and then check if this end is greater than this one and this end is less than this one. And we can always know these indexes. Like for example, if we say this decreasing segment starts from L to R, this is R plus 1 and this is L minus 1. Okay. And I'm going to set L as -1 and R as -1 as well. Wait, do we have... Okay, if n is equal to 1, we can just say yes, and we can reverse from 1 to 1. This is the edge case because... Oh no, is it? Yeah, okay, that's not edge. Okay, we'll see. Let's solve it for the general case. If AI is greater than AI minus 1, no, I plus 1, that means our segment is decreasing. Yep. Yep. If this is the case, and if L is equal -1, we can just set L as I, and R can always become I plus 1 maybe. And let's say we had multiple let's say we found multiple decreasing segments. If that's the case, we don't need to worry because our case is gonna cover it. Wait, can we just reverse this part and check if it's sorted? Yeah, I think we can. Let's just try it. Okay, the corner case is we don't have any decreasing subsegment, which for this case we're going to just print yes and 1 1. And otherwise we're going to reverse from a begin plus L to a begin plus R. And check if it's sorted or not. If it's greater than the next element, that means it's not sorted. For that case, we're just going to print no and return. Otherwise, we say yes and print L and R. I think the index starts from 1, so we need to increment the both values. What is it now? What is that? Zero to two. After reversing it, what happened? Three and one? Wait, it's not. Oh, we should reverse it until r plus 1 because the second parameter is not included in the reversing. Okay, yes, 1 2 3 and yes, 1 2 2. This is no. And this is yes. Okay, we can make it just lowercase yes, lowercase no. Okay, I hope it gets accepted. Boredom, that's why whenever he gets bored, games. Okay, for this case, you can just delete 2 and 1 gets deleted automatically. For this case, you can delete 3 and 2 gets deleted afterwards. And for this case, he deletes 3. All elements equal to 8k plus 1. Okay, for this case, he can delete 3 and then all the 2's gets deleted, and then he can delete 3 again, and then he can delete 1 1, which is gonna bring him 8 points, but that's not optimal. For this case, he can delete all the 2's. Okay, we can use DP. I want to create a DP with size of this maximum AI, so that is 1 to the 5th, and an initialize array A to it and then sort it maybe. Wait, do I need to sort it? Yeah, I do need to sort it. And only then I can run from begin to end. Okay, dpi dp of ai is equal to wait. Okay, it's basically the number count. It should be count of ai. Okay, let's create another count array. Oh, wait, no, I created it wrong. It should have been like this. Yeah, and we can just literally increment dpx by x, and dpai is gonna be incremented by dpai -2. So which means, for example, if which means the maximum coin that you can earn by deleting number equal and less than 3 is, okay, here's what I mean. dpi represents the max point that you can earn by deleting number I. Deleting all the number equals I. So for this case, we cannot delete dpi -1 all number I all number less than equal to I. For this case, we cannot delete I -1 because we're deleting I. Oh, actually it's maximum of these two. Okay.
Okay, I think I know how to fix it now.
We can always come from ai -1, which means like if we were to delete 3, then we can delete 1 before.
Okie dokie. Time to get AC.
Maximum of DP3 and DP2. Yup, I hope it's good. And the last answer is DP of 100,000. I hope. Zero?
So,
Okay, we don't run from 1 to n, we run from 2 to 100,000. Okay, still 0. What is wrong here?
okay. That should work. Oh my goodness, wait.
Oh no.
Wait, did I actually just solve div 2f? Hold on. No,
What?
no way, no way. Okay. My brute forcer has not found anything. YOLO! Please. Whoever set time limit to 1 second, you're gay. Please, I beg. Go fastest! 25, please, for the love of G. Please.
Could accept it?
Yeah, let's
Nice.
go! What's the rating of it? Oh. Well, the rating's disappointing.
Ratings.
It should be like high div 2D, but I don't know why they branded it as an F. Whatever.
Okay. Which problem is that again?
So that one is problem Q.
Okay, I have only 7 problems left now. So are you finished with all? Oh, you still have 2 problems?
Yeah, one of them I straight up don't know how to do it, and the other one I've yet to think about it.
Okay. I'll catch up in a few minutes. Okay, basically we need to split this array into 3 parts, which the sum is equal to which all 3 sums are equal. And we have to print number of ways to split the array into 3 parts with the same sum. Oh, we solved this problem before too, right, Silani? Do you remember this problem?
Yeah, I copied my past solution for it too.
Okay. Then for this problem, we can just find the prefix sums. Prefix sum, the key should be long. We can use unordered map, and we need some count, and for prefix sum we can have only single variable, and prefix sum plus equals x, and count pre-sum is gonna plus, and our answer is count. Wait, we first need to check if the total sum is divisible by 3 or not. If it gives some remainder, we have to say 0. Otherwise, we know for sure it's divisible by 3, and it's gonna be number of occurrences of pre-sum divided by 3 and times number of occurrences of divided by 3 times 2. Hope it works. Yes, 2. 9? No. Oh, I forgot. Like, the index, like the place it's occurring, has to be after the place where this is occurring. I forgot that. So then what can I do? Okay, for that case, I can just find the sum first, and then that means we don't even need this counter. We can just have count 1 and count 2 both equal to 0 at first, and we run through the array again.
I'm gonna go sleep in like 20 minutes. Problem R.
AI, and if pre-sum is equal sum divided by 3 times 2, and then we're going to increment our answer by count 1, and we're going to increment our count 2. Otherwise, no, not otherwise. Pre-sum is equal sum divided by 3. Then we're going to increment count 1. And should have get 1. 2, 3. Oh, okay. It has to be n minus 1. Yeah, because we cannot include the last element in the second segment. It's 2 and it's 0. Hope it works too. Okay, what is this problem about? We have R red and G green be blue balloons. Need exactly 3 balloons. 3 balloons attached to some table shouldn't have the same color. The maximum number T of table can be decorated if we know number of balloons of each color. That's weird. Okay. For first test case, how is it for? RGG, GBB, BRR. Okay, RGG gives us, after RGG it becomes 4, 2, 3, 4, 2, 3, 4, 1, 1, and 2, 1, 0, and it's finished. Okay. Okay, so this statement basically means just all 3 balloons cannot have the same color. It can be 2 same and 1 other. Okay.
Well, actually, the wrong answer on random teams. Shoot.
What? You got
I
wrong
got wrong
answer on
answer
random
on.
teams?
Yeah, when I try to submit to code forces.
Oh, okay. MN. Okay, I'm on problem N now.
What is problem at? Let's see. Oh, that one is one of the problems of all time.
What does that mean?
I feel like it's just a problem. Nothing special. It just exists.
Oh, oh yeah.
It's just there for you to beat.
Okay. Hey Hamza.
What's up?
Yeah, you're on the stream, by the way.
Wait, you're streaming on like YouTube or Twitch? Where are
YouTube,
you
YouTube.
streaming?
Times 2 is less than A2. Less than or equal to A2. That means we can always pack one of the first kind and one of the second kind and two of the third kind.
Oh my gosh.
Yeah, it might overflow because these numbers are pretty dangerous. If this is the case, we can make no, not this number of. If this is the case, we can make only A0 plus A1 number of tables. Otherwise, we can make the maximum, I believe. Oh, it's N. 4 and 1 and 2. Yeah, seems like it's working. I will double check my solutions afterwards on Code Forces. There is yet another problem. Longest substring, that is regular brackets sequence. Okay. Oh, okay. It's like finding the maximum subarray sum. I feel like you just have a string and you can find the current sum, which is equal to 0, and you can store the maximum one. Wait, current sum. also 0, and maximum value as well. Okay, I hope it works. Oh, n is just equal to s dot size. Okay, curve is gonna be incremented by s if si is equal to closing bracket. We're going to add -1, otherwise we're going to add +1. And if our current is less than 0, which means the regular bracket ends here. And if this is the case, we're going to shift our L to I plus 1 and clear the current and continue maybe. And if our current is equal 0, we can update our maximum length. Maximum length is I minus L plus 1, maximum of max and I minus L plus 1, and this is our current regular bracket size. And yeah, I guess it's it. Oh, and also let's count how many substrings are equal to max. Okay. If it's equal to corlen, we're going to increment count. And if max is less than corlen, we're going to update the count, set it to 1, and max is equal to corlen. I think it's good. And count should be 1. Start from 1 and yeah, and we just print max and count. And oh, 6 2, and this one is 0 1. Serratia and brackets.
If you know how to solve that one, then GG's. Because I just don't know.
Okay. Okay. Each of them is described by 2 integers. Maximum correct bracket subsequence of okay, like Oh, length of maximum correct. Bracket subsequence of sequence. I see. Okay, initial string is of size 1 million and queries are from 1 to 1 million. Let me think. Yeah, if we do segments around it, it's too messy. Are there any easier approach?
Like, before I thought like the question was asking for like subarray of the entire query, which I'm pretty sure is impossible
Mm-hmm.
to solve in less than linear time. But like, since it's subsequent, I think that simplifies things much more, but it's still not trivial, certainly.
Mm-hmm.
Like I thought about the typical strategies with merging halves, like divide and conquer, segmentary, and all that. But how do you even do something like that with subsequences? Because like
Yeah, that would be so messy.
I guess if you keep track of the balance, then it might be doable. But the problem is that becomes like often squared because you have to know for each half interval like how many the maximum length such that the balance is currently that, and that's just so bad.
Mm-hmm. Yeah, I'm thinking of sparse table solution. Like we can find every, like from the initial array we can find every we can pre-compute every correct bracket subsequence, right? Like it's
Okay,
just similar
yeah.
as the previous problem. And from there we can build probably a sparse table, like starting from index I, what is the maximum length of correct bracket subsequence array. Yeah, I'm just thinking of that way. Haven't find the solution yet.
If I also thought of kind of applying the solution from I think it was the problem before where it's a substring. So you can basically do the same DP and treat it like a subsequence, but then like that becomes like problem where it's like from 0 to I was the longest route subsequence. How do you remove the prefix that you don't want from the DP?
Oh, that's hmm. I don't think it's gonna work.
Yeah, I don't think it works, but
Yeah.
I just thought, why the heck not? Think about it a little bit.
Yeah, let's just see if I've solved this problem before on Code Forces. I guess not. Oh, this
Apparently,
problem
this is
difficulty is
a
not really
very
bad.
famous problem.
Oh,
So
really?
yeah, I don't think there's any special tricks with kind of like taking advantage of the fact that queries are offline.
Mm-hmm.
Like I don't see how you would take advantage of that either. Even if you know all the queries beforehand, you still am trying to solve the base problem. Like
Mm-hmm. Yeah, and if okay, I kind of have an idea. Let me just brainstorm. So every time we see opening bracket, we increment one, and every time we see closing bracket, we decrement it by one, and we can keep track of the sum, like the prefix sum,
yeah,
and it should give us something like this kind of mountains, right? Do you see my live stream? I can share my screen on Discord.
sure, yeah, I'll see.
Yep. And
Oh yeah,
yeah, here we know that like from here to here we have correct one, right? Correct brackets.
yeah.
And from here to here we also have correct brackets. So starting from every point, the next like intersecting until the next intersecting points we have correct brackets, right? So let's say for example from here to here we have correct brackets. And if we are asked to answer query from like for example here to here, we just need to find the maximum width of the mountains, right? Basically.
Oh yeah, because then this way
Yeah,
you
for
can kind of shift your thing since it's cumulative. So I'm just thinking of a case where the query starts at the downhill.
oh like
So
here.
obviously yeah, so like you obviously want to cancel that part out somehow.
Yeah, I
And
don't want to get this, right?
yeah,
Yeah, this doesn't count as a mountain. A mountain is only not down, but like it has to be upwards, right?
yes. So
Hmm.
I feel like it's maybe this is the way because it's basically just shifting the mountain up and down. And if some values go below the line, then they probably won't count towards the answer anyway because you've already offset it. So
Mm-hmm. Oh, there's also like, what if we have these prefix sum and ask to answer from this L to this R? Then we should answer this.
hmm. Hmm. Because obviously we want to look at values of hmm. Because it's like what data do we work with? We actually don't want to work with the peak because that just basically means only left bracket. We need right brackets to close it. So like if we take the difference between, but then how do you deal with the multiple peaks? That's another thing of its own. Well, maybe
Wait,
we pre-compute some data for that too. Um,
can we do binary search maybe? Like for example, if you can find correct bracket with we will always guaranteed to find we can find the correct bracket with v minus one minus two, right?
yeah,
Yeah, probably we can use that.
but I don't see how we deal with multiple mountains with that.
Deal with multiple mountains.
You know, like the above example you've drawn where you have two peaks, technically.
Oh yeah.
So how would you
I
count?
mean, I thought we can do it like this. Like for example, if we like for every point, if we start the next intersecting point, we can always start like for this point we can start this x value, right? This x value is this width, and for
Yeah.
every point we can start these values, right?
Yeah.
and
Oh.
and from here.
Oh, what if?
Mm-hmm.
Okay, maybe what if instead of the bounds, we have wherever there's a right bracket, we add a one. So that kind of signifies exists there. So we just like pretend that it matches some left bracket for simplicity. And then when we try to correct it, because that will handle that top case perfectly. So now to correct it, okay, how do we correct this?
Mm,
Oh, because it's a subsequence. I have to keep that. So
yeah. Okay, let's see the problem again. For each queries we have to answer with only single number, which is the maximum width. Which is the maximum width. Hmm.
I'm just imagining if we have a query, it's all right brackets. How do we say no to that?
Queries. Okay.
Like if we have a bunch of nested brackets,
Mm-hmm.
maybe we can base on some greedy idea that in that case we would. Oh, never mind. That runs into the same issue. Uh, hmm.
Oh wait, I think I found the solution. Okay, so
Well, let's hear it.
basically we can find like every correct substrings, right? Every
Yeah,
correct brackets, like from here to here, here to here, here to here, every single one of them. And
yeah,
we can store every correct subsequent. We can always represent them as Li to Ri, right?
yeah,
And we're going to store each one of these segments into their length. Like we're going to have one map, and map length is gonna be array of these kind of segments,
yeah,
and Ri and so on. And um, and then we can sort these segments by the starting value, right?
mm-hmm.
And we're guaranteed that none of these two segments are overlapping. Oh no, just kidding.
Yeah,
It can overlap. For example, like if we had this kind of substring, it's when the length is equal to 4, we're going to have this and this, right? Okay, it doesn't matter. Like, let's say it interacts, doesn't matter. And it's just sorted as
mm,
Li, sorted by their
yeah,
left value. And then when we're asked to answer query L and R, then we're going to do binary search
yeah,
on the length. And for length, okay, so let's say we're trying to find if we can find the correct substring of length x. Then we're just going to find from map.x, and we're just gonna do binary search from this array. Does that make sense? Like, let's if we say this array is equal to a, like
yeah,
a is equal to map.x, right? Then we can just do
yeah,
binary search on the left value. Left values are sorted, and we're just going to do perform binary search and on L. Like, we know this L value, and we just need to find some segment that Li is just greater than L, right?
mm,
Like if this
yeah. I
stands,
see your idea. Yeah,
yeah, if this stands, we that means we can find subsequence of length x. Then we can try to increment it and then try it for the higher values.
mm.
Yeah, that's my idea.
I'm thinking, how do we join multiple subsequences with this? So
Like, what do you mean?
you can imagine. Let's just say you have a query of the entire string. If you have like a left and right brackets, like few of them spread out, and in the middle is just all right brackets. It's like we want to join some contiguous substrings, which is the subsequent part. So it's like, how do we even efficiently do that?
Oh, we can just store it in the stack. Yeah, I think so. Like for
Yeah,
example, if
but maybe we run the stack once to get some information and then
yeah,
because there's no way we run a stack for every query.
no, we can run stack only once, and we will pre-compute these values like these ones. Yeah, let me just think how we can implement the stack.
Oh, I see. Yeah, so in that case, your thing will catch multiple disjoint substrings. Yeah, because then you just get the amount of, well, the problem is they can overlap, but then they will belong to different lengths. So yeah, I see.
Yep. Mm. And how do we catch that? Oh, wait. That's gonna cause another problem. Like, let's say we have this kind of initial string and so on, like this much. It has
Yeah,
length of 1 million, right?
yeah,
And then we have um, around 500,000 correct substrings of length 2, and like around 250 correct substrings of length
yeah.
4, and so on, which is like already storing these substrings are gonna cause time limit exceeded, so we cannot do that.
Hmm.
Okay, that doesn't work.
Maybe like another thing I just thought of is since we're basing everything, kind of like our entire balancing thing on when we first encounter left bracket and so on. So when we're given a query,
Mm-hmm.
it can shift the balance. So that means all of our values can be entirely off because I imagine there are some cases where if you have a query and you're forced to start at a certain point, some things are going to be possible, but the ones we pre-computed first is not. So but maybe we can get around the issue somehow.
Hmm. Like by fixing, what do you exactly mean?
Well, you can imagine. I mean, it's just in your example, so we're drawing the lines connecting two intersecting points, right?
Yeah.
They could be any arbitrary point. So that's visually saying where the balance is where you start. So it's not always at zero.
Mm-hmm.
I'm trying to think how I gotta go to bed in 5 minutes. I'll try to think of something. What if the subsequent part were just I'm starting to think more and more about your like mountains idea.
Mm-hmm.
I feel like there's something there.
Yeah, I'm also thinking like as we can see from here. Oops. As we can see from here, it's actually these two are connected, right? These two mountains can be connected.
Yeah.
So that means we can point from here to here and then here to here again. So it's like having a parent point. So that means like starting from this eye, if we jump only once, let's say just jump 0, then we will get J. And if we jump twice, we get this, let's say this point is K, then we get K. And depending on the segment, we can adjust the jumps. And for this example, we can like point this way. And the initial head is gonna be this point. And starting from this point, like something like binary jumps we can do, but finding the initial and optimal head is gonna be problematic. I don't know how to do that yet.
Because we can very easily compute given some interval. Well, we pre-computed with a stack. It's like given this range, how many? Well, it's literally just the difference between positions. So if we have a list of that and we query the oh bro, I gotta go to bed and my laptop's gonna die. So
Okay. Sure,
yeah,
see you
see ya,
later
bro.
then. You also know that our substring cannot start in this purple line. Like these purple lines are inhibited. Like you're not allowed to start the subsequence on this, which makes the problem a little bit easier. Then we can find the earliest possible starting point of the substring in range L to R, and we can just jump from there, I think, because it's always efficient to jump from here than jumping from around here. because as you can see, these guys are gonna always end up here and no future to jump again. And if this jump exceeds the next R value, like for example, if the R was here, then we can safely say that okay, what can I say? Okay, let me think. Probably it could have been like this. I'm just thinking, like, if that's the case, we can say that this is the answer. But is it? Just thinking, like, for example, what if it was like this? Even if that's the case, we can find the same substring here. Yeah, okay, I guess this approach might work. Like, we pick a point, like in the segment L to R, we're just gonna find the leftmost possible start of the bracket, and we go from there. And oh wait, that's actually not right. Like for example, what if we had like this? And this is our L, and this is our R, and this is our answer. But if we start from the leftmost possible start of the bracket, it's just not right. Like, maybe less leftmost of the each mountains. Then at worst case, each mountain can be like 2 lower than the previous one, or just 1 lower than the previous one. Like this difference is 1, and this difference is 1. This difference is 1. Then in L to R segment, we will need to check for multiple mountains. That is not good. Okay, it's pretty late today, so I guess I'm gonna walk over these hard problems tomorrow. Okay, see you later. Bye bye. Oh no, before I stop I have to check my previous solutions. Like if they don't work, it's kind of embarrassing. Okay, problem A solution. Okay, it's accepted. Odd divisor. Okay, first 3 problems just got accepted. Oh, this guy also posts the solution of the problems. I hope I submitted the correct problem. Hit the lottery. Was D, right? Okay, it's D. And E is young physicist. Chatron code forces. Oh no, is it code forces lagging or is it me? Young physicist. Oh, they both got accepted. Yeah, I was about to submit to chatroom, which is F. Chatroom submitted raising bacteria. Oops. Interest drink. Interesting drink. Wait. Could I do that? No, since I don't know the problem name, I cannot do that. What? Oh, I solved this problem a long time ago. Yeah, it looks pretty similar. I just want to submit to this particular problem. get accepted. Pursue ball. Should be high, I assume. Yep. Random teams. It's J. This might fail, these random teams. Oh, nice. Got accepted. And sort the array. Just the next one. Yeah. Boredom. And what was the next one? Number of ways. This was M. What? I got wrong as run. Test case 12 on boredom. Did I not use long long? Ah, that's the case. Should have been long long. Yeah, should have been long long. Yeah, I'm gonna resubmit it again. Okay, number of A's is correct. Table decorations. Wait, is it that hard problem? Like, I feel kind of not sure about my solution. Like, what is this? What is the rating of this problem? Like, what? What? The other one got accepted as well? Wait. Like, table decorations is 1800 problem? No way. Like, look at the code. It's not 1800, guys. It's way too easy. Yeah, that problem is just too outrated. And this one is like 1900? Oh my god. These problems must have some rating inflations. Wrong as run 4? How is it possible? Interesting. If it's less than 0, we can just immediately break out. Oh, and also at the end, our current can be greater than something something, and for that case our current line is gonna be n minus L plus, no, only n minus L and minus curve and we can do exact same thing here. Yeah, that was a mistake from my end. Yeah, I hope now it works. Long as run 1. What was the first test case? Six and 3? Wait, how? Like there's literally 2 out there. What? Oh, also we cannot have the last. Wait, what? 6 too, but when it's ended, it's just adding more. Yeah, we can check it if core is greater than 0. We can just do this and close this issue. Four, and this one is also, wait, okay, this one is also 4. No, yeah, also 4. Then our answer should be 4, 2. 8, 1? How? No, 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 no. It should be 4, 2. Okay, we can rewrite the solution real fast. We can just store for each core sum, store the latest end of latest, no, the most oldest begin of each. Okay, okay. Minus, minus. Okay. Min with the I. Otherwise, otherwise, Kurlang is dp kursam I minus dp0 is equal to -1. Yeah, for 2. Now it's 6-1. It should be 6-1. No, it should be 6-1. wait. Wait, do we even need to do this? Probably no. Yeah, probably no. Like, why do we need that? Seven one? No. No, that's not right. 81, 81. Can we just make it math? The count is equal to 1. The mark is gonna become correlate. At I equals 7, it's saying 7. 3, 4, 5, 6, 7. Negative 2. Okay, negative 2. Negative 2. We had negative 2 here. It should be. Oh, it's being 0 for no reason. Not good. Erase. Cursor. 11. No, 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 no. Yeah, I put the sign incorrectly. Let's just comment it for now. Let's run the initial test case. 6.2. Second test case 0.1. No, 0.3. Cow. -1, -2. Which of all size? 0. Okay, that makes sense. Okay, let's try. Okay, 28. I guess it's gonna get accepted. I need to resubmit the boredom too. It's problem L. Okay, yeah, I'll solve the rest of the problem tomorrow. Okay, see you. Bye bye.